With those materials, are we still progressing? Have we landed on the perfect one? What's
it's continual and it's really continual for us. So we've been working with UQ now, so for probably almost 4 years now, and doing different testing of different materials. And when we moved to, we were the first here in Australia in any industry to get the new sort of HP 3D printers, which probably people are starting to see in the market now. A couple of labs have them.
Yeah.
We were the first worldwide to get it for this application. And the first material they had come out was a PA12, which is a nylon. So it's a nylon 12. There's many substrates of nylons. You wouldn't notice the difference between most of them just touching and feeling, but it's just how they're made up of. And we had PA12. That's how we're making all our parts. We've got all our testing done with that. And it's a really good material. Like nylon 12 works well. We've got tens of thousands of parts out there in that. But then about 12 months ago, almost nylon 11 or PA11 come out as well in through these printers, and that's what we've been using now. And that's the material looks and feels exactly the same pretty much, but it's got a better elongation strength, so it means you can flex it a whole lot more before it'll ever fatigue and that method. So it's about 50% more than what PA12 is. So not that we had issues with PA12 or nylon 12, we just thought nylon 11 was a better material. It just suited our game because these things are always under load the whole time. So we want to make sure we've got the best fatigue and flex properties. So then about 12 months ago, we just transitioned all our parts to nylon 11. The next iteration, I guess, you can actually get like polypropylene now as well with it.
It's poly.
Yeah, so it's just about a material that started to be released. It's not widely available. We haven't got our hands on it yet, but hopefully in the coming sort of 6 months or so we can. We'd have to weigh up if there's any benefits to going back to poly. A lot of the reason why poly's used, it's a very good, you can heat it up. It's got good flex properties, but it's indestructible. But the reason why it's been widely used in this is because it's really cheap as well. But it's not the best plastic to machine. It can have some challenges, hence why I was saying at the start it was quite difficult for us initially.
Absolutely.
So that's happening. There's other different, you can get sort of nylon with glass beads and that, which makes it a whole lot more rigid.
Okay.
But the big exciting one is there's a material called TPU, which is just forgot for the life of me what the acronym stands for, but it'll come to me in a second.
look that one up, guys.
Look that one up. But it's an elastomer, so it functions like it's like a rubber compound. You print it solid, it's really hard, but you can actually print it in different structures. It makes it you can change the shore hardness, like the density of it.
Okay.
And so that potentially could be a substitute for EVA devices, and that's something that we're sort of putting some R&D into now as well.
Absolutely, game changer.
Yeah, so we're continually doing R&D with our the PA11 to make sure that we, I guess, maintain part qualities, everything. So we have internal processes where we can determine if there's any part issues or powder issues with our materials. We need to make sure that happens. Because through the time there's been failures with printed devices. And that's why we're continually doing the R&D to make sure that doesn't happen. And PA11's been a really good compound because we just literally haven't really had any issues with it. So yeah, but we just need to keep on developing.
Progressing. Absolutely. Now you did, I guess you just mentioned that as well. With these poly ones, they are cheap, which is obviously, that was a great thing for a lot of clinics starting up. What is the cost like for the 3D printed ones? Like, is it actually significantly more? I mean, obviously the techs, there's a cost with the tech, but is it costing more to the practitioner? Is it costing more to the patient? Like, what's
one of the biggest goals doing the R&D was to not to get a product that we could replicate out, but not then have it at the point of then having to charge more for it. Okay. So that was really one of the big, I guess, criteria we had when doing it. So we've always charged the same as what we were for, like, the polypropylene is what we have for 3D printed. Now, the makeup of that pricing is different in terms of the cost price to when you're manufacturing. The raw material for this is cheaper, quite a bit cheaper. But then the cost of capital is lower as well to do it. But then with the printed ones, you have this change where the cost of capital is a lot higher. So that, a 3D printer to do this on scale could be sort of $750,000, like for the high end ones. But then there's savings that then can happen from, I guess, obviously the material component where you save it from recycling, but then also like some wage costs and that as well in terms of, finishing and that, because you don't need to sit there and grind, all that anymore, because the devices will come out when they're sort of looking like that. But for us, it just allowed us to scale our business. So it's not like we've, taken staff off our production or manufacture line. It's actually the opposite. It's actually allowed us to grow significantly. So that's sort of how we maintain that sort of same cost is, we pay more for the materials and to produce it, but then we have some savings in other areas as well.
No, very good.
Yeah.
Okay. And what other stuff are you 3D printing?
By chance, because we were sort of, I guess, not at the leading edge, but I guess the first to sort of start to implement this 3D printing technology, not just in orthotics here in Australia, but broader for 3D printed plastics and that, using the materials and hardware we use. It's bizarre, but orthotics now prints a lot of just different parts for the wider industry, our engineering. So we print a lot of drone parts, we print a lot of engineering parts.
Interesting.
Hobbyists, so a lot of custom car parts.
Yep.
Yeah, but there's a massive people are sort of restoring cars, and it's obviously hard to get
those little bits
that was made 50 years ago, and to go and get that one-off part made is really expensive. So we get a lot of different things. That a lot of the rev heads who have all these little custom parts, and they're hotted up. Skylines and that, hubcaps and that. We actually print quite a few of them as well. So, it's quite a strange way how we went from just printing sort of, orthotics and that to drone parts and car parts. So. But we, in our industry now, we actually are starting to do a lot more in sort of like, UCBLs and ankle foot orthotics, and actually then broadening up the spectrum that we can sort of print. Yep. And the practices that we deal with are sort of upskilling the podiatrists to start prescribing more, because we can as podiatrists, but we just haven't, just because it's been hard to manufacture or not trained.
Yeah, exactly.
Enough to do it.
Yeah, prior to that, I've never really reached out to someone to get my AFOs done and that sort of stuff, but it's actually very easy through iOrthotics, which I've found. Not a plug, but just saying.
We only do it to our clinics that we sort of have along the way that we supply to with that at the moment, but it's going to come to a point where we can sort of start to branch it out a lot more with it. But it's a changing sort of way, because the reason why 3D printing is great with things like AFOs and UCBLs, and that is when you're doing the machining method, so you're cutting away from a block of plastic. If you've got, say, a heel cup on this device that's 50 mil, but your plastic's only 40 mil.
Where are you getting that from?
Correct. So you can't do it. Exactly. So then if you want to do like, medial flares, you've got limitations on it by doing it this type of manufacturing way.
Yes.
Whereas one of those benefits with 3D printing is that what you call design freedom, and also that ability to sort of make any sort of complex part. So we can produce a heel cup that's 80 mil high, that's got a lateral flare, or it could be an AFO. We can print anything as high as up to about 300 mil almost. So almost just below like an adult size AFO, like a full AFO, you can print. So it's pretty exciting, and it's starting to change it for some of the practitioners that we supply to. They're starting to sort of broaden their scope a lot more now.
Absolutely.
And then it's just, it's those little things where you can start to like customize products differently, put people's names and clinic brandings on them. And it's just another way that we can, I guess, put a feather in our cap as a podiatrist to offer a better quality product, just because there is more competition out there in the market nowadays. Spruiking that they can do what we can do. So we've got to just continue to
keep
push
going,
the boundaries.
keep pushing. Exactly. Yeah.
So,
okay. Good.